Is time travel actually possible? The answer is a tale of two directions. For traveling into the future, the answer is a definitive yes. But for traveling back into the past, science says no. Physics classifies time travel into two distinct categories. Forward motion through time is a proven fact of relativity, while backward motion remains purely theoretical and currently impossible. While science fiction often visualizes time travel as a mechanical journey through a portal, real-world physics focuses on the curvature of space-time and the limitations of entropy. We are currently capable of moving forward through time, though usually in ways too small to perceive in our daily lives. Forward time travel is not fiction, but scientific fact. Albert Einstein's theory of relativity proves that time is relative, not absolute. We call this time dilation. Time actually slows down for an observer moving at high speeds compared to someone at rest. The math is precise. As your velocity v approaches the speed of light c, the time interval stretches significantly. It happens with gravity too. The closer you get to a massive object like a black hole, the slower time passes for you. As an object approaches the speed of light, time slows down significantly for the traveler. This is best understood through the light clock analogy. When stationary, light travels vertically. At high speeds, the light must traverse a longer diagonal path, causing time to dilate for the observer. The effect grows exponentially. As velocity nears the speed of light, the time dilation factor approaches infinity. We observe this in the Large Hadron Collider. Subatomic particles called muons usually decay in nanoseconds, but by accelerating them to 99% the speed of light, their internal clocks slow down, allowing them to live longer and travel much further. Gravity warps the fabric of space-time. The stronger the gravitational pull, the slower time passes for an observer. This is gravitational time dilation. Massive objects create deep wells in space-time, curving it. As you move deeper into these gravitational wells, your experience of time stretches out. As of 2026, data from the Event Horizon Telescope has confirmed this effect with 99.99% precision. We literally age differently based on our distance from a massive body. This means that time is not universal. It is relative to your specific location in the gravitational landscape of the cosmos. Mathematical models derived from general relativity suggest that backward time travel is theoretically possible through pathways called closed time-like curves. To create these paths, we would need to bend space-time beyond what natural gravity can achieve. We would require exotic matter, a substance possessing negative energy density. Currently, this substance exists only in equation sheets. We have neither observed it in macroscopic quantities nor found a way to synthesize or stabilize it. Until we can engineer space-time, the past remains unreachable. If backward time travel were possible, we encounter the famous grandfather paradox. If you traveled back to prevent your grandfather from meeting your grandmother, you would never be born. This creates a logical contradiction. If you were not born, you could not build the machine to go back in time, meaning your grandfather still meets your grandmother, and you are born again. To resolve this, 2025 AI-assisted simulations suggest the self-consistency principle. It posits that history is unalterable. Even if you traveled back, physics would prevent you from changing anything. Any action taken in the past is already part of the timeline, fulfilling the loop instead of breaking it. Closed causal loops become self-sustaining. You don't rewrite the past, you fulfill it, ensuring the universe remains consistent despite our interference.